Okay, so here is our exam. I'm not sure why I can't write an E there. Exam problem number 5. And this is, I'm going to call this Keaton's way, because I didn't think about doing it this way, but I really like this. So if you were successful and felt pretty comfortable about number 4, Keaton had a very nice idea here. So in number 5, we're given the same PDFs. So we have f1 of x1 is equal to 0.2, and that's on 0 less than or equal to x1 less than or equal to 5, and f2 x2 0.1, and that's 0 less than or equal to x2 less than or equal to 10. Now, what Keaton did, and my only issue with this is probably renaming things, but here we want to look at y equal x1 minus x2, and what Keaton noticed was, well, hey, isn't that just x1 plus a negative x2? And yes, it is. And so I can probably do this the way I did number 4 if I do a change of variable. And so what we're going to do is we're going to actually introduce x3, and x3 is equal to negative x2. And so what that means is that f3 of x3 is 0.1, but that's for negative 10 less than or equal to x3 less than or equal to 0. And so now if I just approach this the same way I did with number 4, now I have y equal x1 plus x3. And so I know that 0 has to be less than or equal to x1 less than or equal to 5. I know that negative 10 has to be less than or equal to x3 less than or equal to 0. Now, again, if I use this and I say, well, let's solve for x3. x3 equals y minus x1. Then I can substitute that into this second inequality, get negative 10 and y minus x1 less than or equal to 0. Again, subtract the y from everything, so I get minus 10 minus y less than or equal to negative x1 less than or equal to negative y. Now multiply through by the negative 1 and switch the inequalities, and you get y less than or equal to x1 less than or equal to y plus 10. And so working with 0 less than or equal to x1 less than or equal to 5, and y less than or equal to x1 less than or equal to y plus 10, then remembering, of course, that y is, well, now I put a 0, but that's not correct, right? Y is between, since I'm adding something that could be as small as negative 10 to 0, y could actually be from negative 10 up to 5 in this case. Okay, so y is from negative 10 to 5. And so once again, we need to take these and figure out our bounds. Okay, so if we start y at negative 10, what happens up here? The negative 10 on this side is no issue on that second inequality for x1, so x1 is greater than or equal to 0 still. And so then, and it starts at 0 on the right-hand side, but so it increases, and so since it starts at 0 with y plus 10, it's bounding the x, so y plus 10, and that will continue until we get to, let's see, what happens? I guess until we get to -5, because at -5 we hit the top end of the x1 and we get to a 5. And so then, okay, so that's that one. Then from -5 on, well, at -5 we still get a 0 from that second inequality, because y would be -5. That's not bounding x1 at all. But once it hits 0, it would, so we'll stop at 0. And on the right-hand side, when we've hit -5, 10 plus -5 is 5, and so, well, x1 can't be any bigger than that. So as y increases here, x1 just stays between 0 and 5. And then finally 0 less than or equal to y less than or equal to 5. And in this case, what happens? Well, let's see, if y is 0, then we're bounding on the bottom by y. Because as it gets bigger, this, again, the second inequality is impacted as y gets bigger. But y plus 10 is always bigger than 5, so x1 can never be bigger than 5. So we have that. And so now we start our integrals. So I have an integral from 0 to y plus 10 of my 0.02 dx1, and I'll only do it with dx1 in this case. And so this is 0.02y plus 0.2. Okay, for our PDF, and so that is for -10 is less than or equal to y is less than or equal to -5. Okay, then 0 to 5, so that's an easy one. 0 to 5, 0.02 dx1. That's just 5 times 0.02, which is 0.1. And so that is for -5 less than y less than or equal to 0. And then finally y to 5. 0.02 dx1, which is equal to 0.1 minus 0.02y, and that's from 0 less than y less than or equal to 5. Okay, so there's our PDF for our f of y, and definitely we could check this to make sure it works. I'm not going to do that, but there we go. As long as I did my integrals correctly, I believe we have our Keaton solution to number 5. So, nice job on thinking about that change of variable. I like that.